Hello. Oh yeah, Alicia, I couldn't find the lecture notes that you posted on the Google Drive. Did you post them under the lecture notes or where did you post them under? Hey, Camilla.
Hi.
Oh yeah, are you familiar with the carboxylic acid derivative nomenclature now? Because I saw that you did like the Levin's practice problems worksheet for nomenclature.
Yeah, I did some. I just kind of struggled with anhydrides and then amides.
Anhydrides and amides. Oh right. Yeah, those are the little tricky ones. We'll try to work through that as well because like I'm kind of rusty on those as well. But we'll see. We'll try to like explain the ideas together. But before that, let's go over the practice problems that I found here. Um, so for these problems here, I want you to either draw the structure or provide an IUPAC name. So if I give you a structure like this, I want you to provide the name. And then if I give you a name, then I want you to draw the structure. So let's first start with the first one here. This is an ester right here. So how would you name this ester here?
Starting with the R group, which is a methyl ethyl,
Right? Methyl ethyl.
and then 2, 3, 4, 5, and then it's a pentane, but then there's a methyl on carbon 3.
Right? Methyl and carbon 3.
And then there's also stereochem,
Mm-hmm.
which it's R.
Yes. Oh my God. It is R because when we do the highest priority, which is going to be this 1, 2, 3, that's going clockwise, and we keep it like that because the lowest priority group is on the backside. Dang, your 118A skills are still there. That's good. That's good. So that's going to be R, 3 methyl, pentanoate.
And just to clarify, the R groups or the R group goes before the stereochem.
Yes, the R group goes before the stereochem. That's right.
Okay,
The stereochem will go with the rest of the name.
got you.
Uh-huh. Okay. So what you could do here is like, do you have like an iPad or a notebook or any like writing material
Yeah.
to use? Yeah, you could draw that and then take a picture of it, screenshot it, and then send it to me through text, and then I could double check that.
Oh, okay.
Uh-huh.
Perfect. Thank you.
Yeah, uh-huh. Oh, and Elysia, for the 118A problems, send me through Discord what you want to go over. And then we'll go over that after we do these 118C nomenclature problems. Right. And we'll go back
Okay.
and forth. Yeah. Thank you. Hey, Hannah. Hey, Ryan.
Hello.
Hello, hello. How's school going so far? Like microbio, uh, AP Lang, high
AP
school,
Chem.
AP Chem. Wait, are you studying that already, or is that next
Yeah, we're
semester?
studying that. There's fall work.
Oh, you're starting that after like next week or something?
Well, there's like a quiz every Thursday, and like
Uh-huh.
it's too hard to like fit all of like 1 year of college chemistry
Yeah.
into like one semester. So they're doing it like you study at home and then you take a test on Thursday every week.
Wait, in one semester, not 2 semesters, like not the
It's
regular school year?
no, you go back to class after like learning about like almost like half the material, and then you go back to like because like AP Chem is next semester, and yeah.
Oh, AP Chem next semester, so they just give you homework and readings to do on your own time to prepare for next semester?
Yep.
I see. That's good. That's good. Yeah, yeah. So if you have any general chemistry questions, you can ask here. And then if I remember, I can help you. But I'm still reviewing Gen Chem and Biochem, but I want to pick it up again. Okay, I got the image. Let's see this. So what you put was this. Boom, boom, boom.
Oh wait, I forgot to put stereochem.
Oh, right. Sterochem. Because this is a Z alkene. What did you
Yeah.
draw here? You drew an E
It-
alkene.
Yeah, it should be the same side.
Yep, the same side. That's right. It should be like this right here.
Yeah.
2, 3, 4. Right. So this one right here, it is a carboxylic acid where our number one atom is gonna be the carbonyl carbon. And then if we find the chain, the alkene starts at carbon 2, which is good. And this alkene is a Z alkene, but our longest chain has to be 5 carbons long because of the pents here. And we have dioic acid, meaning that we have 2 carboxylic acids, right? One carboxylic acid at one terminal end of the molecule, and then the other carboxylic acid at the other terminal end of the molecule. So it's gonna look like this right here, right? Where this is our main chain, 1, 2, 3, 4, 5 for the pent. The alkene, the Z alkene starts at carbon 2, and we have 2 alkenes in this whole structure because of the dioic acid. Right,
Okay.
2 carboxylic acids, right. So be careful of the dioic acid. Whenever you see dioic acid, carboxylic acids are always at the terminal end of the molecule, like always at the end of the molecule, right? Just like an aldehyde is, always at the end of the molecule. So when you see dioic acid, always draw 2 carboxylic acids at the end of the molecule like that.
Oh, I have a quick question. It's not related to this problem, but I had doing the leave-ins practice. I have a question whether the double and triple bond endings, like the ene and the ine, go at the main chain root, or is it like, because I wrote it before the like butanoate. I put ene and then butanoate, but the key was butene 08. I'll send you a photo.
Okay.
A second, sorry.
And that's okay. It's okay. I think I know what you're talking about. Like they put like for the ester in 08 instead of in 08, right? Like you try to put like the number in 08 or let me see. Okay, I got it. J. Let's see. Oh, right. So you know how in the first name you put butanoate?
Yeah.
That AN is not supposed to be there because that's saying that it's an alkane, like a propane, butane, pentane, cyclohexane,
Okay.
which shows single bonds. But we have a double bond, so we have to put butene to show that we have an alkene in the molecule name, right? So it's part of the suffix. The alkane, alkene, or alkyne is part of the suffix. So
Oh,
if it's an alkene, it would be ene. No wait.
okay, perfect.
Yeah. Right. Now that is gonna be perfect because this is gonna segue to this problem here. Let's try this one. Okay, I got it. Let's see what you got. Right here. Ethyl 3-bromo 2-propene oic acid. Yep, that is correct. 3-bromo 2-propenoic acid. The only thing you're missing is stereochemistry. What kind of alkene is this? E or Z?
E.
Yep, nice, nice. Yeah, you got it. You got it. Yeah. So don't forget about stereochemistry in this name. Uh-huh. Nice, nice. Let's see. Okay. I'll give you some time to draw the next one. Okay. Okay. Let's see this. And the R group of the O would be an ethyl group like
Yeah,
that.
I
You got
forgot to write that.
it. Nice, nice. You got it. You got it. Uh-huh. Right. Correct, correct. Do you know the substituent name of a ketone? Like if a ketone is substituent, not the main chain.
Oxo,
Oxo, yeah, oxo, oxo. Uh-huh.
but it's lower than carboxylic acid.
Yeah, it's lower than carboxylic acid,
Okay.
where this is our 1, 2, 3, 4, 5 carbon main chain highlighted in yellow. And then our two substituents here would be that and that. Okay, now let's name this. Yeah. So how would you name this structure here? What substituents do you see, and then what number?
Oh, 3-methyl
Uh-huh.
4-octopentanoic acid.
Yep. 3-methyl 4-oxo pentanoic acid. You got it. Uh-huh. Nice, nice. Right, right. Okay. Now let's draw the next one. Here. These are the last two. Okay. Okay. We got this, yep, and then amide NH2. Yeah, you got it. Nice, nice. Uh-huh. Yes. Now let's move on to this last one. This last one where we have to provide the name for. And don't forget the two H's on the nitrogen as well, for the amide. So what would be the highest priority functional group in this structure here?
The acyl halide.
Yep, the acyl halide, which is going to be specifically the acyl chloride. So this is going to be our number 1 atom, 2, 3. So that's our longest chain, that 3-carbon chain. What is this substituent here on carbon 2?
Methoxy. I'm
Yep.
not sure.
Yep, methoxy, 2-methoxy. Right.
What if it was instead of a methyl group an ethyl? It's
Yep.
just it's the OXY ending.
Ethoxy.
Ethoxy. Okay.
Ethoxy. Yeah, and then if it's 3, then it will be propoxy. Yeah.
Okay.
Right. So if it's like an ethyl group, then that'll be 2-ethoxy.
Got you. Okay.
And then on carbon 3.
The phenol?
Yeah, phenol, 3-phenol. So alphabetical order, 2-ethoxy, 3-phenol. And then do you know the suffix name for this acyl halide or acyl chloride?
The oil?
Yeah, oil chloride. But we have the longest chain, 3 carbons long, which is going to be propanoyl chloride. Yeah. Okay, so that's the acyl halide, ester, amide, and carboxylic acids. The anhydrides is probably the trickiest one. Like I need to brush up on that a little bit, and then I'll come back to you with those practice problems, and we'll do more amide problems too with the N, big N.
No worries. Thank you.
Yeah. No problem. So Elysia, do you have any problems or questions that you want to go over for 1 A?
Yeah, I think I put in some practice problems into the file.
Yeah, let me.
I say like what I kind of am struggling with is like working on like the harder structures like or I guess like moving from like kekule to bond line, but it's like the more difficult ones, like the long ones.
Right. I'm trying to find the file. Did you upload it to the last, like the file that I sent you, or the most recent folder that I sent you?
Yeah, I think I put it into the practice problem exams. I probably didn't send.
Oh yeah. I don't see it.
Okay, I'm so sorry. I think it was like loading and then I just didn't go through. Let me see. Let me try again.
Okay.
Or can I send it to you through via email?
Yeah, you can send it to.
Okay, I think it'll be quicker that way.
Yeah.
Sorry. What's your email?
BryantOckham@gmail.com.
Okay, I'm gonna try putting it into files again. I'm so sorry.
No, it's okay. It's okay.
Um, do you happen to have any structures on your end? And like if
Yeah, I do have structures.
anyone to
Let me
okay.
go bring that up. ABC. Mhm. Zero. Okay, good. So the problem was converting a kekule structure into bond line form.
Mhm.
Okay, okay. Wait, actually, let me just do it here. It's probably faster. Yeah, there's a lot of columns. Yeah. That's good. Okay. Yeah. So this one here is asking to draw the condensed formula, but we could just do the bond line formula instead of the condensed formula. So let's start with A.
Okay.
Okay. You could try drawing it on your iPad or notebook and then send it to me on Discord, and then I could double check it for you here. Or you could
Okay.
explain it to me, your thought process, or whichever one is easier for you.
I think I'll take a screenshot and then I'll write it in you said
Okay.
condensed formula.
Yes. And
Okay.
that's right. Oh,
Okay,
I
and
see
then I'll
that.
get back to you on that.
Okay.
I did send you some more specific problems I through Discord because I was able to input it into the folder, so I'll have to try again.
Yeah. It's okay. It's okay. Let me check the thing. Yeah. Try drawing out these four structures right here. Send it to me, and then I could double check your work, and then we could go over the concepts as well. And then while you do that, I could go over some 118C problems, and then go back to this here.
Okay, that works. Thank you.
Okay. Okay. Have you learned any reactions in the carboxylic acid chapter yet, Camilla? Or let me check. The most recent lecture that you sent me was the most recent thing that you went over, right? Like on the lecture slides, which was this one right here.
Wait, I'm sorry. Can you repeat the question one more time?
Yeah. Did you go over any reactions yet for the carboxylic acids?
Not yet.
Uh-huh. Okay. um, let's see. Do you want to like what else do you want to work on? The reactions, nomenclature, the acidity, basicity of carboxylic acids. What other questions do you have?
Could we start on some of the reactions?
Yeah. Uh-huh. So here. Uh-huh. And then Eliseo, when you have the bond line structures ready, send it to me, and then we can go over that.
Okay, sounds good.
Uh-huh. Okay. Yeah, there's a lot of reactions. We could go over like how to make carboxylic acids, or we could go over the new material. Let's go over the new material of carboxylic acids. Here. So I'll show you this table. Here. Where carboxylic acid is the parent function. The derivatives are acyl halide, anhydride, ester, amide, and then the amide could be primary, secondary, tertiary, and then a cousin of this family is going to be nitrile. Right. I put it in this specific order because the most reactive derivative is going to be increasing from right to left. Right. Let me put the carboxylic acid in between the anhydride and ester. Right. Okay. So there are two factors that would explain why the acyl halide is the most reactive derivative and the amide or nitrile is the least reactive derivative. The biggest factor is going to be the leaving group ability, right? So the reactivity is going to be based on the leaving group ability. The other factor is going to be the electrophilicity of the carbonyl carbon, right? Where these blue circled things right here are going to be the leaving groups, the variable groups of the carboxylic acid derivatives, right? When they leave, they're going to leave with a negative charge. So I'm drawing out these groups as they leave with negative charges. Right. We see that this is the best leaving group because the negative charge on the halogen is the most stable. Since the halogen is the most electronegative atom, which is able to hold the negative charge the best. We also see that for the anhydride right here, this is the second most reactive derivative because it has the second best leaving group, right? The negative charge on this oxygen right here can do resonance with this carbonyl right here. And if something can do resonance, it is more stable, right? Now, if we compare the negative charge of this oxygen versus the negative charge of this oxygen right here, the negative charge on the OH oxygen is more stable because it does not have any electron repulsion. right? There's no R group donating electrons into the oxygen, making it less stable, right? Whereas this oxygen minus here attached to this R group that is an EDG by induction is less stable because this R group here is donating electrons inductively to this oxygen, where that's going to be decreasing the stability because negative charges repel each other, like charges repel each other, right? Whereas this hydrogen here is not an EDG. That hydrogen is not donating electrons, which is why this oxygen minus here is more stable than this oxygen minus right here, right? The nitrogen is the least stable because nitrogen is less electronegative than oxygen and halogen, right? So the biggest factor is the leaving group ability, which explains why this is the ranking system of how reactive the derivatives are, right? The other factor that's not as important is the electrophilicity of the carbonyl carbon, or how positively charged the carbonyl carbon is. So if we look at this carbonyl carbon of the acyl halide right here, this halogen is the most reactive, most electronegative atom, which is going to withdraw the electrons, making this carbonyl carbon the biggest partial positive charge, right? Oxygen is not as electronegative, so the partial positive charge of the carbonyl carbon is not as positively charged, right? The reason why I said the electrophilicity is not as a big factor as the leaving group ability is because the anhydride, carboxylic acid, and ester has the same atom, oxygen, which has the same electronegativity, which would pull on the carbonyl carbon the same amount, right? Which is why the partial positive charge of the carbonyl carbon is going to be the same. But nitrogen here, since it's the least electronegative, it has the weakest pull of electrons. So it's going to pull on the electrons of the carbonyl carbon the weakest, giving this carbonyl carbon the smallest partial positive charge, right? So it's probably best to just know the leaving group ability because that's the more important factor, and this list right here, right? Okay, so another important thing to note is that the top two most reactive derivatives are going to be the acyl halide and anhydride, where I'm going to make a separation between them because this separation will explain why these top two most reactive derivatives do not require heat or an acidic or basic catalyst, right? Whereas the lower reactive derivatives here, they're going to require heat and mostly acidic conditions. There's going to be some problems with basic conditions for some of them, and we'll see why in the mechanism. But they require either an acidic or basic catalyst. Most likely going to be an acidic catalyst, right? So I'm going to give you another chart that will explain this, right? So let's say going from like down to up is going to be increasing reactivity, right? The most reactive derivative we have is the acyl halide, and then we have the anhydride, and then the ester, and then the amide. And then the carboxylic acid is the parent functional group right here, right? One of the reactions that you're going to learn is hydrolysis, right? All of these carboxylic acid derivatives right here can be converted to a carboxylic acid by hydrolysis, right? So the acyl halide, it just needs water to convert back into the carboxylic acid. The anhydride also just needs water. It doesn't need anything else to convert back into the carboxylic acid, right? But for the ester and amide, since they're the less reactive derivatives, they're going to need water and acidic conditions, most likely, and heat. If you use basic conditions, right, then you're going to have the carboxylate, the deprotonated version, and then you need to do an acid workup to get back to this carboxylic acid form. So I'm going to use acidic conditions just to go straight into the protonated version. So the same thing for amide. We're going to use water in acidic conditions and heat, right? We need the acidic catalyst and heat to convert the lower reactive derivatives into the carboxylic acids. So the blue arrows here that I drew out, those are the hydrolysis reactions. We're converting all of the carboxylic acid derivatives into the carboxylic acid, and that's called hydrolysis. Hydrolysis, which is one of the main reactions. Hydrolysis. Okay. Yeah. Oh, so Leo, the line says Gur, lose that's redox reaction. This is yeah, something else. Something else than redox reaction. Right. Now the most reactive derivative here, the acyl halide, they can be converted into any one of the lower reactive derivatives in one singular step. Right. So think of it like this. The more reactive derivative can be converted to a lower reactive derivative in one step. So that means the anhydride can be converted to an ester in one step and an amide in one step. But it cannot be converted to an anhydride in one step. Right. So that also means that the ester here can be converted to the amide in one step, but the ester cannot be converted to the anhydride or acyl halide in one step. We'll go over the reagents for these like soon when we go over the mechanisms. But another thing is that to convert this carboxylic acid to the acyl halide, we could use two reagents. We could use SOCO2 if you want the acyl chloride, or you could use PBr3 if you want the acyl bromide. Right. So let's say that you want to convert an ester into an acyl halide. You cannot do that in one singular step, right? Because the ester is a lower reactive derivative than the acyl halide. You would have to do multiple steps, where the first step you would have to do is hydrolysis back into the carboxylic acid. And then from the carboxylic acid parent functional group, the base functional group of this derivatives family, you could convert that into the acyl halide using SLCO2 or PBr3, right? And then from this most reactive derivative here, you can make any of these in one singular step, right? So that's going to be a possible synthesis route that you might see, right? So this is going to be the majority of the reactions in the first midterm, right? There's going to be a few other things like converting a carboxylic acid to, let's say, an ester. You could use an alcohol, and it has to be in acidic conditions only, cannot be in basic conditions. The reason why it cannot be in basic conditions is because that basic conditions would deprotonate that carboxylic acid to the carboxylate, right? And your professor might include heat. Some professors don't include heat. I'll have to see like his notes to see what he wants. But this can only happen in acidic conditions, never basic conditions, right? Because basic conditions would deprotonate this carboxylic acid. This reaction here is called Fischer esterification. If you wanted to convert an ester into a different kind of ester, where the R group is different, you could use an alcohol with the R group that you want. And this could be in acidic or basic conditions. you might see here as well. And this is called trans esterification. Because we're changing the type of ester, changing the type of R group, esterification. Okay. So let me highlight that, trans esterification here. And Fischer esterification here. So Fischer esterification creates an ester from a carboxylic acid. Trans esterification creates a different type of ester from the original ester, right? So this table right here is going to be the majority of the reactions in midterm 1, which is basically this table right here. Where is it? Right here. Right. A few other ones that you might see are Hoffman rearrangement and what was the other one? Rearrangement. We went over that, went over that. Yeah. Okay. Yeah, so that was a overview of what's going to be on the midterm, majority of the midterm there. Right.
Thank you.
Yeah, no problem. Okay. Elysia, you have the online structures of the structures I sent you?
Yeah, I think so. I sent them to you through Discord.
Oh yeah, let me see. Okay.
I think what kind of confuses me sometimes is like I know there's like there may be the same bonds but different carbon attached like multiple times in the same row. So then I think to add parentheses, but then also I know like if there's a methyl, you kind of want to demonstrate that you're you're branching out from that carbon.
Branching out from that with the parentheses, that would show us the
Yeah.
branching out part.
Yeah, but then like I kind of also included the parentheses for ones that were repetitive through, or like that repeated through the same chain. I think that's kind of what confuses me though, because I'm not sure if that's right or.
Oh, okay. Let's check this. CH3, that's this part. That's right. CH2, right? CH, right? And then the CH3, the branch is that part. That's right. The CC is that triple bond right there. And then the CH2 is that CH2. And then we have the CL. So yeah, this CL with the parentheses here is good, but that is optional. The parentheses is optional, but it's good that it's okay that if you include it. CH right here, and then CH because we have a double bond, and then the aldehyde CHO. Yeah, nice. The first one is good. You got it.
Okay, thank you. Yay.
Let's go. Let's see your second one. CH3, CH3, 2, CH2, CH, OH, CH5, O, CH2, C, O, CH2, CF3. Okay, so this is the. Oh, I see what you're doing here. This C is the C, right? Like that you put right here.
Yeah.
Notice how that central carbon atom has 1, 2, 3 methyl groups, 3 CH3s attached to it. What you could do is you could put the
C and then CH3 in parentheses and then put 3 subscript.
Yes, like this. Right. Because what you did was you separated one CH3 and then you put the other the two other CH3s here, but we can
Mhm.
combine them into one parentheses with the three
Okay.
subscript right there. Right?
That makes sense.
We're representing thing right here. Nice. CH2, CH, OH, CH. Oh, wait, so put CH5. This 1, 2, 3, 4, 5 thing right here is going to be CH2. Right? Because each carbon has 2.
Oh,
Right?
right.
The
I think I made a mistake there.
1, 4, 5. Right. CH2, 5, and then O, CH2, C, O, the carbonyl, CH2, CF3. Yes. Nice. Okay. That's good. Let's go to the third one. Okay. C2, C. Yeah. So this is gonna be this problem that you did. The do you see what else that you could have done?
Let me
Look at the branches attached to the central atom. What's the central atom, and what are the branches attached to it?
it's connected, or like there's 3 of the same connected to that one central. So maybe
Yeah.
CH3, CH2, subscript 3, C.
Yes. CH3 subscript 3. You will combine these together, that one and these two together into 3.
Okay.
That's what you want to do. Once you find the central atom, which is this one, and you use the same branches, repeating branches, and those repeating branches will be into the parentheses. CH3,
Okay.
CH2, 3. Just like that.
Okay. And we would put that at the very
Uh,
beginning, and then the carbon that it's attached to.
Yes, we at the very beginning, because the carbon in the central atom is not at the end. It's somewhere in the central atom, at the end, which is why we put that at the beginning. The branch is at the beginning.
Okay.
H, O, H, H2, CH, CH, COO, CH3. Okay. The two right here, then two parentheses, at least 3 CH2s. 2 CH2, not condensed, like it's too good at that. You would actually have to draw 2 times.
Oh, okay.
Hello, can you guys hear me?
Yes.
Okay. Yeah. So now the next thing you have is the CHOH, that's right, and then CH2. CH. Right. So like this, whenever you have subscripts, you cannot put 2. It has to be at least 3.
Oh,
Right.
okay.
So for this case, we have to actually write the CH and CH. Yeah. Okay,
So
which
then
is
it
gonna
would
be
be CH. Okay.
yes, CH. And then this would be that CH branch CH3, and then the ester COOCH3. Yeah, this you got it.
Okay.
Now this one you put
I think for the last part where it has the CH3, that's. Did I do that? Okay.
to C R C L C H F C H CH2 CH3 CH2 O C CH3 2 CH3. Yeah, that's okay because it's at least three, which
Okay.
is good. You could condense that into the parentheses like that. But if it's two, then you have to write CH2 right?
Okay.
And another important thing for the condensed formula is that whenever you have an aldehyde, a carbonyl attached to a hydrogen, that is always going to be represented as CHO in the
Okay.
condensed formula, right? Which is going to be this CHO right here. CHO, right? Because if you put COH, it's going to look like an alcohol. Yes,
Yeah.
an alcohol,
Okay.
right? But to distinguish that from an aldehyde, we put CHO. Now CH, CH2, CBr, Cl, CHF, CH, CH2, CH3. That's a branch. Parentheses. That's good. CH2, O. Yes. C. And then the two methyl group branches. Parentheses. CH3 2. And then CH. Two CH2 CH2. 3 CHO. Yeah. Nice. You got it. Let's do it.
Okay. I did want to ask one thing. So I think another thing that I was wondering if we could just like do one problem with is like doing bond line, but with like something like that as well. But there were like more specific problems in the discussions.
Oh wait, on the
Which you
Discord that you sent me.
I there's some there, and there's also some like in the discussions manual, which everyone's
Discussion
easier
manual,
to
yeah.
access.
I think I have access to that. Is there a specific problem that you wanted to go over from the discussion manual?
Any one of the first like practice problems that have us do online.
Okay.
Oh, the game closed.
Let's see. Week 1, drawing organic structures. 3 here, drawing bond line structure. Oh shoot. Practice. Convert the given condensed format. Okay, I see it. Number 3, page 25, 24. Let's see. Let's do one that looks hard.
Okay.
Let's do J, K, and what else? J, K, and E. J, K, and E. Let's do E. Where's EJK? EJK.
Okay.
E is saying CH3 to CH2. I haven't looked at the key for this yet, so we'll walk this together, and then hopefully we get it right.
Okay.
NH, CH2, CH3. So for the condensed formula, when you see parentheses at the beginning, those are the branches.
Right.
Whatever the parentheses are attached to, which is this carbon right here, that carbon is going to be the central atom, central carbon, which is what I draw out first, which is going to be that point right there. And then I know that that central carbon has two methyl groups, so I'm going to draw the two methyl groups coming out like this and like that, right? Which are going to be representing the two CH3s here, which are those two CH3s right there.
Okay.
Coming out at the end. And I know that the next thing is a CH2, which is going to be like this, right? This is the CH2 that it's attached to. And I know that since this carbon has one hydrogen, that's this invisible hydrogen right there. That one invisible hydrogen is this one hydrogen right there.
Okay.
Right. And I moved on to the next thing, which is this CH2, which is going to be represented by this CH2 right there. Right. Now we see another parentheses group, which I know that that's attached to some sort of central carbon. The other central carbon is going to be this one right here. Right. Which is going to be this carbon right here. And see that this carbon right here has no bonds to hydrogen, right? No bonds to hydrogen. And it has two bonds to a methyl group. So I'm going to draw those two bonds to a methyl group coming out like this, 1, 2. And then the other carbon is going to be this carbon right here, which is that carbon right there.
Okay.
And you notice how this carbon right here, which is, I said it's the carbon right there, it has no hydrogens as well. What can we do to make this carbon have no hydrogens, but attached to an oxygen and a nitrogen?
Draw two, like, for one for oxygen, one for nitrogen. Like connected to that carbon.
Right? Let's say the nitrogen is right here, and then one oxygen right there. This carbon here has 3 bonds, 1, 2, 3. So it looks like it has one invisible hydrogen right here. Right? But we don't want double bond, right? We want a double bond somewhere. And which atom do you think the carbon will have the double bond to? To the oxygen or to the nitrogen? To the oxygen, that's right. We want the double bond to the oxygen like that. Carbonyl, right? Carbonyl. And we see that this nitrogen right here is attached to a hydrogen, which is going to be like that, and a CH2, CH3 like this. CH2, CH3, which is this CH2, CH3 right there. And what kind of carbonyl is this? What kind of specific carbonyl do we have here? What is it next to?
Nitrogen. Oh,
right.
Is
like,
it
ignore the
amide?
Yep, the whole thing right here is an amide.
Yeah.
Right, because
of the carbonyl.
Yep, the carbonyl is next to this amine, but we don't consider this an amine because the amine is next to the carbonyl, making it an amide.
Right.
Nice, nice. But if the carbonyl was not there, then we would have an amine. Right. Does that make sense for that part, E?
Yeah. Do you think they like typically ask those on like quizzes, or would it be like more of a like a test question? Like to like name the groups at least.
Oh, the functional group. They would actually draw it out for you, like the groups, and then they want you to list out the functional groups present in the molecule that they give you. Most likely, I haven't seen a quiz where they make you draw the bond line structure from a condensed formula or kekule structure, and then after that ask you what functional groups are present. But when you do these types of problems, I would do it anyway just for extra practice. Because when they do
Okay.
ask you what functional groups are present, then you'll be extra prepared for that.
Right. That's good. Thank you.
Yeah. Yeah, no problem. Because don't just use like the practice material questions. You could create your own set of questions by like asking what groups are present, but they might not give the key for that. So when you like try to ask yourself questions, like you could send it to me, and then I could like double check it for you to check your answer. That's good.
Okay.
So let's go on to the last two here, J and K. So J is going to be NH2, CH2, CH2, NH, C, CH2, CH3, 2, CH, CH, CH2OH. Okay. You try walking me through this problem, and then I'll see how you go.
Okay. I think that our central atom is going to be that first carbon. So, I want to say that the carbon's attached to first the two hydrogens, but then also the NH2.
Right? Which is going to be the NH2 right there. And then the two hydrogens right here. I'm going to let that's invisible. Right?
And then our next one would be the next carbon, which that one would be attached to two hydrogens, so two hydrogens hiding there.
That's right.
And then connected to, I want to say the next carbon, and that carbon has a nitrogen and a hydrogen attached to it.
Like this right here?
Yeah. And then
Right. So when we have a nitrogen right here, for a nitrogen to be neutral, it wants to have 3 bonds to be neutral. Right now, it only has 2 bonds, 1, 2. So it's not going to be neutral. When we see stage 2 like this attached to an N, then that's going to be attached to that N right there. Right, which is the N right here. And then that N is attached to hydrogen, which we have to draw out the hydrogen explicitly. This hydrogen we cannot draw as invisible because it's not on a carbon. Right? The only time when we have to draw out a hydrogen explicitly when it's on a carbon is if it's an aldehyde. If it's an aldehyde, then we have to draw that H out of the aldehyde, of the tro. Right? But if the H is on an oxygen, nitrogen, or any other atom other than carbon, we have to draw that out explicitly like this. Right? And then this carbon right here is going to be that carbon right there.
Yeah, so then that one would have 2 sets of CH2, CH3. So one way would have a CH2, CH3, and then it would also be attached to another one.
That's right. Which are these 2 right here.
And then the next one would be another carbon with a hydrogen.
Yes, a carbon with 1 hydrogen. And how can we make this carbon have 1 hydrogen and the other carbon attached to it also have 1 hydrogen?
I'm assuming we add another bond.
Yes, a double bond, right? To ensure that this carbon will have 1 hydrogen and this carbon will also have 1 hydrogen like that. This is the double bond right here.
Right. And then that part, I say that there's a carbon that has 2 hydrogens and then an alcohol.
which is the CH2OH right there. We finish it off like that. Nice. So this is the overall structure right here.
Okay.
Right. Now, what functional groups are present? Let's do that as practice, extra practice.
Well, there's the alcohol for sure. Is the NH2 an amine?
Yep.
Okay.
And yep.
And then methyls.
Ethyl.
I mean ethyl, yeah.
Right. So an ethyl is a substituent. It's not a functional group. We call these substituents.
Okay.
Substituents, right? What about this one?
That would be a alkene.
Alkene, yes, alkene. And this one? It's also
an amine.
Yep, an amine. Right.
Yeah.
Because there's three different types of actually 4 different types of amines. How many other carbons is this nitrogen attached to?
2.
Right, so we see that this nitrogen here is only attached to one carbon, which is this one carbon right here.
Oh yeah, carbon, yeah.
One carbon, right? And if it's attached to one carbon, we call that a primary amine. And we symbolize primary as that one with that degree symbol to show that primary amine. Right? How many carbons is this nitrogen attached to? Right here.
2.
Yeah, 2. So we call this a secondary amine. There's also a tertiary amine called tertiary amine or ammonia. Right. So let me show you amines. So this is ammonia, this is primary, this is secondary, this is tertiary, this is quaternary. Right. Ammonia has no carbons attached to this end right here. Primary has 1 carbon, secondary has 2 carbons, tertiary has 3 carbons, quaternary has 4 carbons. But notice for quaternary, we have a positive charge on the nitrogen right here. Right. Because when we draw out the non-bonding electrons, every single nitrogen here has a pair of electrons except this nitrogen, because this nitrogen already has an octet row, 2, 4, 6, 8. So no pairs of electrons needed.
Right.
And then nitrogen has 5 valence electrons, 5 minus 4, positive 1. Right there. Okay, let's move on to the next one. J. Last one here. Oh, no, K.
Yeah, so we have a central carbon that has a 2 methyl groups attached to it.
Right. Oh, see. OCH2, CH3, 3. Central atom with 2 methyl groups like that. Nice.
And then that carbon is also attached to a hydrogen.
Which we could leave out as invisible like that.
And then there's CH with like 4 in a row. So we would draw out a chain that's like 4 carbons, or it's only 1 hydrogen. So does that mean that there's double bonds that exist?
Right, double bonds that exist, which are gonna be shown like that.
Right.
right? Because four of these carbons here will have one hydrogen, one hydrogen, one hydrogen, just like that.
Mhm.
Nice.
And then after that, we have is it another carbon that's attached now to, it's a carbonyl.
Mhm.
Um, uh, and then is it bonded to another carbonyl?
Not another carbonyl, because
Or
look at the order. We have COOC. It would be attached to another
right?
carbonyl if we have COCO, right? Because
Oh,
it would have
okay.
to
So
be
it's
like this
connected to an oxygen.
to the oxygen, right?
Okay.
So the order matters here as well. And then this right here is a special type of functional group, but we'll go back to that when we analyze the functional groups, right?
Okay.
Where this oxygen here is attached to,
As a carbon.
which is this carbon attached to,
Three of the same, which is OCH2CH3, which I feel like I wouldn't know how to draw that.
oh, right. So let's analyze the central atom, which is this one right here, this carbon one, which I'm gonna make that as the pink dot right there. And then I'm gonna highlight the O CH2 CH3 like this. This is the O CH2 CH3, O CH2 CH3, O CH2 CH3, where there's three of them. One, two, three, just like that.
Okay.
Because this is the O right here, and this is the CH2, this is the CH3. And that's one of it. We have three of them attached to the pink central carbon right here.
Okay, that makes sense. Thank you.
Yeah, so there's three different functional groups here. What are the three different functional groups here?
Well, we have double bonds, so that would be considered an alkene.
Alkene, right? That's one unique one. There's two more unique ones.
Is there carboxylic acid?
Yeah, so carboxylic acid would be a carbonyl with an OH.
Oh, sorry. Okay.
It's one of the carbonyls. A carbonyl with an OR group.
Oh, a ketone?
Yeah, so a ketone is going to be a carbonyl with two OR groups.
Oh, ester?
Ester, yes, ester.
Okay.
Which is different than ether, because ether will have ROR, but ester will have the carbonyl with next to the ether.
Right.
And now this one here is the ether right here, like right, the ROR, no carbonyl.
Okay.
Alkene, ester, and ether. Okay, yeah. Did that help?
Yeah, so like I know we're probably not going to be asked this, like at least for now, to show which groups are existing, but like for future reference, how are you asked this? If they were, if or do they ask you, or how do they ask you to point it out?
Like what we just did, like how would they ask a question like that?
Yeah.
They would say convert the given condensed formula into bond line structure and list out the unique functional groups present. Right?
Okay, so they wouldn't ask for you to point it?
Yeah, they would have to ask you to list it, or if they say just list it, then you would just have to like write out a list. But if they want you to like draw an arrow to the functional group, then they would ask something like convert the condensed formula into bond line structure and label each of the different functional groups present in the bond line structure.
Okay.
Right. Yeah. I haven't seen a quiz question like that, but just be ready for that, just in case.
Mhm. Okay, thank you so much. I do have a small question. It's not like anything to explain, but like, for like SP, because that's what we went over in discussions today.
Yeah.
Do you think that's anything like anything new regarding OChem, or is it just like review from like 2C? Because I feel like what we learn for the most part is the same. Like we know the angles, we know the shape.
Yeah, so it is mostly review from Gen Chem. Like the angle, the shape. The most important thing is probably going to be the resonance, like the hybridization of this nitrogen atom versus this nitrogen atom. And then this is going to be a sneak peek of later, but we'll go over that tomorrow.
Okay.
Yeah.
Thank you so much. I think that's
No
all.
problem. Yeah.
Thank you.
Mhm.
See ya. Have a good night.
Yeah, you too. Good night.
Hello.
Hello.
I'm about to finish my AP Chem homework,
Oh,
but
if you came home, what's
yeah,
assigned to
I have
you?
2 questions. Is hydrogen
Yes.
an alkali metal?
Hydrogen, an alkaline metal. Uh,
It's on that side of the.
I don't think so.
Okay, false.
I think it's outside of the thing. Yeah, but I have to double check that.
Noble
Let's
gases.
see. Yeah, hydrogen is not a thing. It's a special element. Does it belong to a family? It's not an alkaline metal.
Yep.
Right. Group are columns. Yes. Periods are the rows. The horizontal rows. Yeah.
Periods. Yeah. Oh yeah. Also, this thing right here. Not this one. Let's see. This one.
Oh yeah. Let me see.
It's my homework.
Oh, this is your homework.
Yeah. This is electron configuration, and basically,
I can fix that. You?
yeah.
Oh my God, is that like a post workout pump?
Huh?
Is that like a post workout pump?
No, I just literally just showed you my arm.
Oh, like as it's resting, or like was this after like
That's something. Just so that's it.
what? Dang. Okay. That's crazy.
Yeah, I know, but like, but for electron configuration, do I just like when they just ask for the what's it called? Wait. I'm trying to find the pictures. Oh man, I lost it. Oh well, it's just like when they're like trying to find like the last answer. Do you just put like what you end up with as the final one? Like when you um
The final one after the noble gas brackets, you put the ones that are not fulfilled. Like the those are not fulfilled.
because like I'm like doing like one for like chlorine, and basically I just kept going, just like labeling all the electron the Bohr model, just like the Bohr model, but like in a linear form. I forgot what it's called, but oh yeah, orbital diagram. That's what it's called.
Orbital diagram.
Yep.
Yeah. I'm I'm not too like familiar with the Gen Con. I have to pick it up and get back to you on that. But like is the answer the XE6S2 5D1 that you put?
I mean, I feel like that should be like what the answer should be, but like just it says use your textbook to find this element on the periodic table of elements, and then just like I don't know if I should be like writing out like all like how I got there or just like the answer.
Oh, it's better you show your work on how you got there and box your answer to
All
show
right,
right. You could
I'll box it right
bracket
now.
X equals just to be safe.
Yep.
Okay. I have to wake up early tomorrow, Ryan. So I'm gonna call it at night pretty early. But we're gonna study on Saturday, right? Oh, on Sunday, right?
Right.
Yeah.
Yeah.
We gotta study, and then we have that talking session too on Sunday night.
Yeah, I
Uh-huh.
got AP Lang homework.
Yeah. If you're like homework to get through.
Yeah.
Yeah, that's good. That's good. What time do you have to wake up tomorrow?
Like 7.
Okay. Shoot, I have to wake up at 4:30 tomorrow to get to the club.
To do what?
We go to a club to train, practice, work out for chiropractic club.
Oh, you gotta work out for it at 4:30.
Wake up at 4:30, brush my teeth, shower, eat a little bit, drive at 5:15, get there by 6 because it starts at 6. It's 6 to 7 because it's a 30-minute drive there.
Jeez, that's
Yeah.
like 6 hours already.
Yeah. Oh, 6 hours? No, that's like an hour and a half until 6.
Oh yeah.
But I'll see you in the work study session and the talking session too on Sunday night.
Mhm.
Yeah.
Yeah.
Good night.
All right, good night. Drive safely.
Thank you.
Yeah, good night. Bye-bye.
Bye.